Hey guys, welcome to today's class. Have fun.
Here we'll be looking at simple interest and compound interest, and here our interest will be represented with the letter I, whereas our compound interest, our principal, will be represented with the letter P. And interest is paid on money saved in the bank or borrowed from a lender. Interest is normally paid on money saved in the bank or borrowed from the, whereas principal is the actual amount of money that is being given initially, which is saved in the bank or borrowed from a lender. Amount, which will be represented with the letter A, is simply what? Is simply P plus what? Plus I. It's simply principal plus what? Plus interest. Whereas the compound interest will be represented with the letter CI, and our compound interest is normally what? Is normally amount minus principal. Amount minus principal. So from this, we'll be making use of these terms to calculate some of the problems that will be given to us. So, and our first example here is given: calculate the amount of simple interest paid yearly at 12% per annum for 3 years on a principal of 150,000. So this is a simple calculation. Just your I, which is principal rate times time. So to calculate your I, your interest, is principal rate times time over what? Over 100. Where our rate, where our P is the principal, and then our rate, which is normally expressed in percentage. We have our rate here as 12%, so it's normally expressed in percentage. So that's what gave birth to this formula that we have, PRT over 100. It was gave back to the 100 we are seeing here because of the percentage. Then the time, T is presented in time, so we have our T as 3 years here. So I is equals to what? P, which is 150,000, times your rate 12 over 100 times your what? Your time. So that gives you what? 54,000. But we have been asked to calculate amount, so our amount will be 54,000 plus what? Plus our principal, which is what? 150,000. So that gives us what? 204,000. Mind you, sometimes they might ask you to calculate the amount of simple interest for 6 months. So if you are being given 6 months, you must note that what? That your time will no longer be in what? In years. It will now be what? It will now be expressed. You have to convert that 6 months, which is not given in years, to a what? To a year. And 6 months to a year is 6 over 12, which is 1 over 2. So automatically this 3, which is represented as 3 years, will now be 1 over 2. So that gives you 150,000 times 12 times 1 over what? Over 200. So but for this we are working with 3 years. So this is the amount on this principal for what? For 3 years. This is the amount gotten from this principal for 3 years. So that takes us to example 2. So example 2 says we should calculate the compound interest on 80,000 for 2 years at 8.5 per annum if the interest is added at 1 year interval. So this for the first year, so this is a compound interest, not a simple interest. So for this, calculate the compound interest on 80,000 for 2 years at 8.5% per annum if the interest is added at 1 year interval. So here we have our principal as 80,000, our first principal 80,000. We have our time as 2 years, and then we have our what? Our rate as what? 8.5%, which is equivalent to what? 19 over what? 2 times 8 is 16. 17 over what? Over 2%. 17 over 2%. So we have our, I think that's all for that. But you must take note of this, that we are being asked to calculate the compound interest for 2 years at per annum if the interest is added at 1 year interval. So our interest here is added as 1 year interval, which means our T is no longer 2 years, but what? Our T will be what? Will be 1 year, because we are being asked to add the interest at 1 year interval. So for our first interest now, our first interest for the first year will be what? Will be P1 times R1 times T1 over what? Over 100. Where we have P1 as what? 80,000 times your R1 as what? Your R1 as what? 17 over what? Over 2 times 100. 17 over 2 times what? 100 times T, which is our time, which is what? Which is 1. So from here you get your what? You get your interest as 6,800. So when you add that up to your principal, that gives you your amount. So which is what? 80,000 plus 6,800. That gives you what? 86,800. So this is our amount for the first year. This is our amount for the first year. But to calculate the amount, the compound interest for the second year, this amount for the first year becomes the principal for the second year. So amount of the first year is equal to the principal for the second year. So the interest for the second year will now be what? P2 times what? Times your R2 times what? Times your T1, T2 over what? 100. So from this we can conclude that what? That our I2 is equal to what? Our P2 is what? Equal to our I1, which is 86,800 times your rate. Our rate is still the same thing, which is 17 over what? Over 2 times our time, which is what? Our time, which is 1, still 1 over 100. So this gives you what? 86,800 times 17 times 1 over what? Over 200. So when you calculate for this, our interest is equal to what? 7,378. So our amount for the second year will be this plus this, which will give us, if you add up this to this, it should give you 94,178. So when you subtract this from your initial, our compound, that gives us our compound. I told us our compound interest is what? Is A minus what? P. So when you subtract this, which is your A, when you subtract this, your A2 minus your initial principal, that gives us 94,178 minus 80,000, and so that gives us what? That gives us 14,178. So that's your compound what? Interest. That gives you your compound interest. But there's also an easier way to go about this calculation. So there's a formula being given for for amount, which is P bracket 1 plus R over 100 to the power of n. So this formula we will use to calculate the amount for what when we are dealing with compound interest. So from here, to calculate the amount for the second year will be equal to the principal, which is what? The principal, which is 80,000 bracket 1 plus our R, our rate is what? Is 17 over what? 2 times 100 here to the power of what? 2, which is 2 years. So if you calculate this, it will now give you 80,000 bracket 1 plus 17 over 200. So when you calculate this, it should give you 80,000 times 1.177. So if you calculate this, 1 plus this to the power of 2, so when you calculate for that, it should be able to give you 1.177. So that gives you a value of what? 94,178. So we've calculated the amount for this, which is 94,178. We went through a long process, but with this formula it takes you shorter. So from this you can now subtract your principal, 4,178 minus 80,000, which gives you what? Your 14,178. So that's the value. But I'm going to show us how we derived this formula. So I'm going to show us how we derived this formula. Okay, so since our compound interest is normally calculated as what? A minus P. So our compound interest is normally calculated as A minus P. So from here we can actually say that that A is equals to what? Whereas A is equal to P bracket 1 plus what? R over what? 100 to the power of n. So let's assume that our A1 is equal to what? Our A1 is equal to P1 plus our I1. So this is our equation 1. So having that as our equation 1, we can actually say that A2 is equals to P2 plus what? I2, equation 2. But while we're trying to find solution to this particular problem, we told us that our A1 is the same thing as what? As our P2. The A1 here is the same thing as our P2 here. So from that we can actually equate that A2 is equals to what? A1, where P2 is equal to A1. So we can say that A2 is equals to A1 plus what? Plus I2. So from this equation, A2 is equal to A1. A2 is equal to A1 plus I2. A1 plus I2, and our A1 is what? P1 plus I1 plus I2. So from here we can say our I2 is equal to P2 times R times what? Times I over what? Over 100. Is that not so? So from there we can calculate that A2 is equal to A1 plus A2 is equal to A1 plus P2 times R times I times T over 100, where our A2 is equivalent to what? Our A1. So we have A2, which is equal to A1 plus what? Plus P2 is the same thing as A1 plus A1 times R times T over 100 over 100. So from here I can actually say that A2 is equals to A1 plus A1 bracket 1 plus bracket 1 plus what? Plus RT over 100. So this gives us our equation 4. So from this we can now, since our A1 is the same thing as P1 plus I1, which we did here, we can now say that our A2 is equal to P1 plus I1 bracket 1 plus RT over 100. So when you multiply this, I1 is P1 plus I1, so this is 1 plus RT over 100. So when you multiply, when you open this bracket, it will give you P1 times 1 will give you P1 plus P1 times this will give you P1 RT over 100 plus I1 times, so I1 times RT will give you I1 RT over 100, then I1 times this will give you plus I1 RT over what? Over 100. So P1 times 1 will give you P1, P1 times this will give P1 RT over 100, I1 times 1 will give you I1, sorry, that will give you I1, then plus I1 RT over 100. So from this we can now say P1 plus P1 RT over 100. We have our I1 as what? Our I1 as P1 plus I1, P1 plus I1, which is the same thing as saying plus what? We have our I1 as P, so we have our I1 as I1 as P1 RT over 100. So we have our I1 as P1 RT over 100. So I2 is P2 times R times 100, while I1 is P1 times RT over what? Over 100. P2 times R times T over 100. So you equate that into I1. So plus your I1 is P1 times RT over 100 times RT over 100. We equate P1 RT over 100 into this times RT over 100. So that gives us what? P1 plus 2 P1 RT over 100 plus P1 RT over 100 all squared. So this is all squared. So that gives us what? A2, which is equals to P1 bracket 1 plus what? Plus P1 RT plus 2 RT over 100 plus RT over 100 all squared. So from this equation we get P1 bracket what? Bracket 1 plus RT over 100 all squared. So when you expand this equation, it should give you this. So it was from here they got that equation. So they got that equation as P A, which is equal to P bracket 1 plus, since our rate is normally represented as R, which is equals to X over 100. So let's say our, here's R. So our R over 100, our T is normally 1. So times 1, that gives you A, which is equals to P bracket 1 plus what? Plus R over 100 square. So that's where this formula was derived from. So here we're going to be looking at some exercise quickly. I'm going to be taking exercise 5A, number 1, number 3, then number 9, and number 16. So from here, for number 1, we have find the simple interest on what? On 6,000 for 4 years at 9% per annum. So our principal 6,000, our year is 4, then our rate is 9 over what? 100. So that gives you 216 over 100, which gives you 2,160. Then for number 3, how many years will it take for 240,000 to amount to 288,000 at 8% compound interest per annum? So this they are requesting for what? The years. So our A equals to P bracket 1 plus R over 100 to the power of n. So our A is 288,000, whereas our principal is 240,000. Then 1 plus our rate, which is 8%, 8 over 100 to the power of n. So here we have 288,000 equals to what? 240,000. Bracket, when you calculate this, it should give you 1.08 to the power of what? N. So from here we have to break this one into a singular equation. So we divide both sides by 240,000. So when you divide both sides by 240,000, this cancel this, then this cancel this to give you 1.2, which is equals to 1.08 to the power of n. So from here 1.08 to the power of n, 1.08 to the power of n, which is equal to this. When you are given such equation like this, it is requested of you to change this this equation to look like this, so I could get for the value of n. So if you are given 4, which is equals to 2 to the power of n, it is requested of you to convert this to this what, to an equation that is similar to this. So in converting it, it will become 2 to the power of what, 2. So from here 2 cancel to n is equals to 2. If you have 8, which is equals to 2 to the power of n, from here, from this, 2 to the power of n is equals to 2 to the power of 3. So 2 cancel to n is equal to 3. So here 1.08 will give us, to the power of 2 will give us 1.16, which is equivalent to 1.2. So that, from that 1.08 cancel 1.08, n equals to what, 2. So they not our, so it will take us 2 years for 240,000 naira to amount to what, 288,000 at 8% compound interest. For the next question, number 9, which says a saver deposits 240,000 in bank, which pays compound interest at 9.5% per annum half yearly. Find the amount in the bank at the end of 1 year. I just want you to take note of that particular word, half yearly. I don't know if you understand. And then our rate is 9.5. So looking at this question, if you are to use this formula, you actually get confused. So I would like you to employ this other formula whereby t was once 1. So that's why we eliminated this t. But here we are looking at what? We are looking at half yearly. So which means our compound interest is calculated what? Every 6 months. Is that not so? Not every 1 year anymore. So it's calculated every 6 months, which is half yearly. So we have to calculate the compound interest at 9.5% per annum, half yearly. So our t is equals to what? Is equals to 1/2. And our n is what? Our n is equal to what? Is equal to 2, because we are calculating the compound interest 2 times in one year, because we are calculating in 6 months. So t becomes what? 1/2, and then our n is equal to what? Our t is equal to 1/2, and our n is equal to what? Is equal to 2. So from here you have 240, which is our p, 240,000, which is our p, times what? 1 plus 19 times 1 over what? 2 times 100 times 2. So our t is 1/2. Then our rate is what? 9.5 is equivalent to 19/2, which gives you 19/2, then times 100. So we have this 240,000 bracket 1 plus 19 over what? 400 to the power of what? 2. So when you calculate this with your calculator, you have 1.0475 to the power of 2. So 240 times 1.05 to the power of 2. 1.04 will give you this. So 240 times this will now give you this. So that's our amount. Our amount in the bank at the end of 1 year is 263,342. So we go to number 16. So our number 16 says a man borrowed 2,500 from his bank at 12% compound interest per annum. So if he repaid 400 at the end of each year, find the amount he owed at the end of 2 years. So we have our P as $2,500. So the interest now will now be 2,500 times our rate, which is 12 times 1/100. So we have our interest as 300, and then the amount will now be what? Principal plus your interest, which is what? 2,800. So the amount at the end of the year, after subtracting $400 will now be what? 2,400. So this will now be what? Our principal for the next year. So the principal for the next year is 2,400, which is our amount at the end of the first year after 400 was subtracted. So we now have 2,400 times 12 times 1/100, which gives you our principal, which is 288. You can't use this formula to calculate this, because you are subtracting what? You are subtracting the amount that is being owed at the end of each year. So we now have 288. So our amount will now be 2,400, which is our principal, plus our what? Plus our interest, which is 288. So that gives us this amount. So the amount at the end of the year after subtracting 400 will now be what? 2,618 minus 400. So we stop here because we were asked to find the amount he owed at the end of what? 2 years. So this is our value at the end of 2 years, 2,288. So thank you. So we'll come to the end of compound interest and simple interest. If you have any question or any comment, you can just leave it in the comment section. Thank you.
I hope the class was interesting. If you have questions, please drop them in the comment section or send us an email. We will love to help you further. See you in the next class.